Around IT in 256 seconds by Tomasz Nurkiewicz. Episode 27. Proof of work.
Let's try to cheat the blockchain. If my wallet has exactly 1 Bitcoin, I can't spend it twice. Once it's written into an immutable blockchain, everyone knows my wallet is empty. However, what if I purposefully create and announce 2 blocks at the same time, with the same parent block? For example, in one of the blocks, there's a 1 Bitcoin from my wallet spent on drugs. In the other block, I spent the same Bitcoin on unlicensed firearms. You know, things you do with cryptocurrencies. There are 2 competing blocks, each having a different version of the history. There is no central database, so the blockchain network has no way of figuring out which block is valid and which is not. Well, they both technically are. A drug dealer may believe in one fork, whereas a gun dealer believes in the other. They both think they received the money and sell me the goods. But the whole network is confused. Which block should be treated as a master branch and which one should be forgotten? Remember, these blocks are conflicting with each other, so we can't somehow merge them. The solution? Both branches keep growing and the network eventually chooses the longer one. That's right. If the branch containing a drug transaction gets another one appended faster, it is considered the only valid one. The block is said to have 1 confirmation. The competing block with firearms transaction is discarded by the majority. Gun dealer is out of luck. Maybe that's a good thing. However, it's still possible that the firearms block will somehow get 2 more blocks appended. So now it has 2 confirmations, 1 more than drugs branch. You see where this is going? Drug and firearms sellers simply keep adding thousands of blocks to convince the network it's their transaction that's valid. Cheating the system is only possible if you can create blocks out of thin air without much hassle. But what if creating a new block was actually expensive in some way, to such extent that creating 2 blocks at the same time would be prohibitively expensive? Rather than introducing some fees, proof of work algorithm was invented. In order to announce a new block, you have to spend a little bit of time and energy. Prove you did some work with your computer. That's why it's called mining. Mining a block requires solving some complex math problem, typically by brute forcing every possible solution. Every participant of the blockchain does the same thing, so they are competing with each other. Whoever is first wins. In order to cheat the system, you'd need more than 50% of the computational power of the whole network. Currently, it means probably hundreds of thousands of CPUs. It's simply not worth it. Moreover, because brute forcing a solution happens simultaneously on thousands of computers, it requires extreme amounts of electricity. We're talking CPU-intensive tasks like computing cryptographic hashes. It is estimated that mining Bitcoin consumes as much energy as many developed countries consume in total. There's one more thing. Bitcoin's blockchain adds new blocks approximately once every 10 minutes. So if you want your transaction to come through, you must wait until someone mines a block verifying it. However, due to forks that can occur with no malicious intent, typically the receiver waits for a while. The most cautious wait for as much as 6 confirmations, an hour. Also, you must incentivize miners to include your unverified transaction in their block by paying a fee. Blocks have limited space, verifying a transaction against gigabytes of history is expensive, so you must pay for that service. Thanks for listening, bye!